Manfred Paul successfully exploited Firefox on stage at Pwn2Own, and in the last video we learned about how he discovered the issue and some technical details about his bug. So with that knowledge, let's head to the disclosure room where Mozilla hears the exploit details for the first time.
This USB stick was just sold for $50,000. What could be that valuable? It's not a crypto wallet, no stolen data and no state secrets. Just a few lines of code. Beautiful but dangerous code. A zero-day exploit. In a back room of a hotel in Berlin, the trade went down. They are the ones who bought it. They are the ones who sold it. And they will make it worthless within hours. This is the story of 2 Firefox 0 days, the world's most prestigious hacking competition, and what it takes to keep millions of users safe.
We already have been in the disclosure room before and the process was basically the same. After we got settled in, Freddy gets handed the USB stick with the exploit files on it to share it with the team offsite. And in parallel, Christian wants to talk to Manfred to learn about the exploit.
While Freddy's looking at it, maybe you can explain to me what you have in store today.
If you watched the previous video, you should be quite familiar with this bug. So, can you understand and recognize some of the things Manfred is about to explain?
Like I always do like kind of mathy bugs. This one, the structure is literally called math space. It was like, so it's in the bounce check elimination, right?
So it's a JIT bug.
Yeah, and it's like basically an overflow bug, but I mean the bug isn't that the overflow can happen because it's about like additions that are supposed to be wrapping and that are supposed to be but they are treated by this exact linear sum. You can do it on like an integer definition, and it exacts like, okay, this looks like a sum of this kind. So if you do like an expression like this, then what happens is these additions get truncated because of the OR. The OR gets like eliminated away. So you have like these unchecked wrapping additions. But because it still passes unknown to this math space thing, it just assumes, okay, the second index is like 5 larger than the first one. So it extends the first bounce check by 5. And if you now have like a really large array, like 2 to the power of 31 or larger, then you can actually have like indices there that like the range goes above 2 to the power of 31 and the range check passes, but the actual addition underflows to something negative.
Okay, yeah, makes sense.
I hope his explanation was familiar to you from the last video. But more important, Freddy just got the files ready. Here he attached the exploit files to the bug tracker and announced it on Slack. POC attachment is up. So engineers offsite can also have a look at it. And Christian is surprised that this issue wasn't found through fuzzing, because the basic building block looks like code a fuzzer would generate.
I wonder why fuzzing did not find this particular bug. Because I mean, it looks sort of complicated, but it doesn't look complicated enough for me to immediately say like I know why fuzzing wouldn't find this, right?
I mean, maybe the large array, right? Because it's...
We have specific code for doing all of this, because large arrays have always been a problem.
And like one subtlety is that if you just do this, it will still be inbounds. It will still be like differentially, you could maybe find it. It will still return something when it should return undefined. But the problem is then like this int32 to int pointer. It has this logic where this, okay, if my only use is for like a load index, then it's like we can't be negative and it doesn't do actual sign extension. And so then this big int constructor also uses like the same int32 extension, but because all uses have to be like caught here, it won't set like the can be negative to false side.
So. Nice.
So yeah, that will be interesting for Christian to analyze why fuzzing didn't find it, and then maybe improve their fuzzer to catch something like this before it ends up in an exploit. But more important to Manfred and ZTI, the organizers of Pwn2Own, is to know whether this is a known bug or not, because that will decide whether Manfred will get the prize money of $50,000.
I'm fairly certain we can say already it's not a duplicate because we already checked beforehand. If we have any kind of JIT bugs open, we usually don't. We don't like keeping these around, right?
Yeah, makes sense.
Yeah, I mean, I guess it should be like a pretty easy fix because, in my opinion, like the correct thing is to just add like this infinite math space. But of course, I don't know like the performance side of things if there's breaks anything or something like that.
By the way, there's one detail about the Firefox exploit and the Pwn2Own competition that I have not really mentioned yet. Browsers nowadays have a sandbox. This basically means websites rendering and JavaScript execution runs in a process that is locked down. For example, it's not allowed to read or write files or execute another program. But of course, if you want to download a file or even write cookies to disk, you need to be able to access files. So this is done indirectly. The content process just tells the Firefox main process to do that for them. This means if you have an exploit here in the renderer, that doesn't give you full access to the system. Usually you need a second exploit to compromise the sandbox, which means in a full browser compromise there are at least 2 vulnerabilities involved. But at Pwn2Own we have only always seen one exploit. And that's because both the exploit from Eduardo and Tao as well as Manfred's exploits were renderer-only exploits. If you look into the detailed rules of Pwn2Own, you can see here that for each browser there are multiple options, and both entries had no sandbox escape and just targeted renderer only. So in theory, they shouldn't be able to pop calculator. The sandbox would prevent them from executing another process. And that's why when you target renderer only in the competition, Firefox gets started with the Moz disable content sandbox flag. This disables the sandbox and allows the exploit to launch the calculator. I just thought this is a small but important detail to mention for anybody not very familiar with browser exploits. It's really impressive to find such exploits, but there's still a lot of work to get the whole way full browser compromise. And that just shows that sandboxes are working, that really make it harder. And so for Mozilla, this is a very important line of defense, and in fact they actually invested time to improve the sandbox over the year. And that's also why Mozilla wants to use this opportunity at Pwn2Own to ask these security researchers about the sandbox, whether it made it harder for them.
I think we discussed this briefly before, that you didn't try to look for a sandbox escape, or you didn't?
I mean, really shortly, but like it was not a lot of time, and like especially with like the changes that were recently, it was like didn't think I had enough time to write.
So you didn't try to find one, or you didn't find one, or you found something that was close to sandbox escape?
I mean, I think I looked at it for like 1 or 2 days or so, but like.
So if you feel like you have something that would lead you somewhere, even if it's half a bug, was really interesting.
I don't think I have anything there. I've like one small thing in the render that I might like report separately, but
in the report?
no, there it's like a different thing. It's like I don't know if it's just correctness. So.
Yeah. We know there are some shortcomings in the recent work we've done that we still have to deploy, right? Despite the major major milestone. So if you were to keep looking, I think let us know. Specifically, we do have a bounty, an exploit mitigation bounty that says if you can provide additional information, even if there isn't a first bug, like even if you don't have a first bug, but you can somehow mitigate and bypass all mitigations in the parent process without a content process, definitely also interested in. Or if you can just bypass the CSP without actually having an injection point, that would also just be super valuable.
Maybe you notice Christian is really focused and typing a lot. So what is he up to?
Yeah, you're bisecting?
I can't actually reproduce it in the shell yet.
Okay.
The proof of concept does not reproduce in any way.
Did you add the begin?
Yeah, I had the begin. What would be the symptom? Would it be a crash? Would it trigger an assertion?
Oh no, it should just. I think it should probably.
Christian is using JS Shell, which is the JavaScript interpreter as a standalone process, not the whole browser, and he cannot reproduce the issue. On the screen from Freddy, you can see the backtrace of the crash in the browser, so obviously the exploit should work. So what's going on?
Did you do Spectre mitigations off? Did you do Spectre mitigations?
Oh, Spectre mitigations.
Yeah, and the JS shell have Spectre mitigations by default, like the browser doesn't.
Yeah, now I get a crash.
Okay.
With spectre mitigations turned off, Christian was able to reproduce it in JS Shell, and we were also slowly wrapping up. On the way out, Christian and Freddy started talking in German, and I overheard them mentioning the spectre mitigations again. It turns out the browser itself runs without spectre mitigations. So if JS Shell has it enabled by default and you couldn't reproduce the issue with it turned on, then maybe that's the explanation why fuzzing JS Shell didn't find it. But that's just my theory. Those are the things Christian will look into later. This time we didn't go back to the office and sat down right in the hotel lobby at the conference. By the way, it's also Saturday, but that doesn't matter much for Mozilla because they are using Pwn2Own as a fire drill to practice when a real in-the-wild zero-day gets discovered. So they are not waiting until Monday. Freddy, being the incident manager again, handles some of the organizational stuff, like preparing the Mozilla advisory announcements, but then also spends some time looking into the exploit to better understand it. At some point, also Manfred joins us eating lunch, and we talked a bit more about the bug, which was really great for Freddy and Christian because his insights are very, very valuable and appreciated.
So what we also did is we looked at could this bug be found by other means, by automated means that we use internally, like fuzzing, for example. While this was not the case for yesterday's bug, today's bug looks a bit more promising in terms of we could find this with fuzzing. We found out that the bug has been around for 4 years. So the question arises, why did no fuzzing tool find this, even though we have lots of fuzzing tools running on this? So there will be, in the aftermath, there will be a deeper investigation. Are there any kind of factors that prevent current fuzzing tools from finding this particular issue and potentially other issues? So this is a standard procedure that we're going to investigate. How can we improve our tools to potentially cover this one as well?
Any hunches what might have been? Why did fuzzers get unlucky, or do you have an intuition for what maybe could be?
I have an intuition right now. So we have multiple fuzzing tools. The test case is not super complicated, but it's also not super trivial. The tool that would be mostly suitable for this case would be Fuzzilli, because this is a JIT optimization bug, and Fuzzilli was actually written to target these kinds of bugs. The problem is that in debug builds, this test case takes quite long to actually run, and this actually exceeds Fuzzilli's default runtime. In an optimized build, you get a crash much faster, but we actually don't have Fuzzilli running with purely optimized builds right now. We do have some other fuzzers running in this setup, but we mostly rely on debug builds because they often give us much more value in terms of assertions. And these are also not pure debug builds. We use debug optimized builds. They are usually very comparable in terms of performance. We still have to investigate why the debug optimized build is so much slower in this particular case. That I don't know, but this could play a role why Fuzzilli wouldn't have found it.
Let's recap the timeline really quick. The exploit was shown on stage around 12 p.m. 20 minutes later, we got into the disclosure room, so around 12:30, the time started ticking for Mozilla to create the patch. Jan, the JavaScript engineer who fixed yesterday's issue, also mentioned that this bug looks quite old and seems to go back around 4 years. But then, not even 1 hour later, Jan said that the fix could be very simple for now by disabling optimization. If we can collect some data and confirm that optimization is not very important for performance, that could be a good emergency fix. Shortly after, Jan pushed exactly this change, an early return in this linear sum function in this special modulo case.
We've shared the write-up and the exploit with everyone involved. We have a patch up that's waiting for review. It already went through a security review. We believe this is fine to land when it has been reviewed by someone else from JavaScript. We started writing security advisories for TBD, but I guess tomorrow, for new versions of Firefox 138.0.4 and the corresponding version numbers for extended support release, which I don't know from the top of my head. Those are also ready to land. So I think we just really wait for the patches to be reviewed, to be built, and then QA to test the new build before we actually call it a new version of Firefox. It seems like it's less of an issue than what we saw yesterday in terms of bringing up a reasonable patch that looks safe. It looks like there's an optimization that we can just try to remove for the time being with an early return, which seems to be a very low-risk patch in terms of security. We will still do some shallow fuzzing for the time that we have while QA is looking at it as well. But I think it should be much smoother than yesterday, where we have to do a variant analysis and look for similar issues.
Yeah, Freddie already mentioned that the patch is very, very small. It's an early return, disables an optimization. There's practically no impact on any other system except performance. And performance we're going to measure, of course, but for a security fix, that's likely acceptable for now. And we can check out what we do about performance in a regular release cycle.
Okay, it seems like they are going for this emergency fix now. But that is not all that has to be done for a release. Here's the Mozilla wiki page about the release process. Under normal circumstances, the code committed in main leads to a Firefox nightly build every 12 hours. Every 4 weeks, those changes get merged into beta, and if then beta turns out to be stable for 4 weeks and the final build is validated by quality assurance, we get a release. So it can take 4 to 8 weeks for a regular patch to be pushed out as an update. But an incident is different. Mozilla calls this a chemspill. Chemspill is a term used to describe a security-driven rapid release. But still, they must make sure to not break Firefox by pushing out a broken release.
So incident process is at this point really just patches landed. So next step is review the patch, make sure that it lands in CI, runs through all of the tests. Then we have test builds which QA can test. And once all of that has happened, we'll ship the release to all of the users. I'm thinking that will maybe be tomorrow.
Completely independent of the of this release cycle, we actually discovered that since yesterday evening, I believe, or yesterday night, there is an issue in the synchronization of one of our repositories. This has nothing to do with the security fix that we're deploying, but it's of course causing issues now in the release process. So people are working on fixing this synchronization so we can actually deploy the fixes to release. Right now, it's not a critical issue though, because we are still waiting for review of the second patch. And as long as we don't have the review for the second patch, we can't land anything anyway. So we assume that this work will now run in parallel. It has been escalated and we will likely fix the repository issue before we actually get the review for the patch.
Now that everything is going towards a release, Diana Smith, a senior release manager at Mozilla, also joins the discussion. And if you read these Slack messages, you can get a sense for that creating a new release is not trivial. But eventually, the patch got reviewed and we are one step closer to the release.
At this point, both of the bugs have been fixed. We've handed over most of the tasks to release management and our folks in North America. I believe we've already gone through CI and completed all of the testing. There will be a bit of manual testing and QA from our side. And I guess we can just call it sort of done from my perspective. And I'm hoping we'll get to release late at night, my time, or early tomorrow.
Yeah, and there was not much else we could do anymore. It was now around 7 p.m. and people in the US time zone took over. At home, I kept an eye on the Slack communications, and as somebody who has never really worked in software engineering, this was really interesting to observe. Especially seeing this complexity behind the release and everything it affects, how many people are involved and so forth. And so let's have another look at the timeline. At 7 p.m. a release build got started. Nightly builds with the patches were already available, ESR builds, the extended support builds also got started, and in parallel there was extensive testing and QA. And then, just 30 minutes before midnight, the new version got released. A new chemspill security release 138.0.4. Basically, this means for Manfred's exploits, it took Mozilla less than 12 hours from hearing about the 0-day to pushing out a release. I think that might be a new record. The year before it was 21 hours that they got even recognized for. Here's the advisory with both exploits. Eduardo Bochin and Tao Yan from Palo Alto Networks with an out-of-bounds access when resolving promise objects, and Manfred Paul with an out-of-bounds access in the linear sums optimization. Anyway, all that is left to do now is I open Firefox and there it was. It's downloading the update and then the famous button appears, Restart to update Firefox. Wow, what a journey. I feel so privileged that I got this opportunity to be allowed into the disclosure room, so thanks so much ZDI for trusting me, and thank you Freddie from Mozilla who had this idea originally. I hope this was also interesting for you. I would really love to hear about what you learned from this entire series, so leave a comment below. Thank you so much for watching, and here are a few last words by Freddie.
So if any of this has been interesting, sometimes we are hiring careers.mozilla.org. We also have a blog, attackanddefense.dev, where we post internals for security researchers, hackers, bug bounty hunters. And yeah, we do have a bug bounty program I believe we pay nicely for bugs. We don't need exploits. Come check it out.
Have you checked out our online training platform, HEXTREE.io? In this crazy new world of AI and agents, you might think that you don't really need education anymore because the LLM can just hack a website for you. But even if I strongly believe that is the future, that is the case, I still think it's extremely important to have a knowledge foundation, because only with a strong knowledge foundation and good understanding of technologies and all these different systems, you're able to actually prompt the LLMs and the agents effectively. And you will be able to realize when they make mistakes. So I still think it's very important to educate yourself and don't become lazy because of AI. Our courses on HEXTREE are basically micro courses. They are very short and each individual video is very short because we don't want to waste your time with an 1 hour long boring screen recording. Also, our courses focus on fundamentals. And by that, I don't mean the beginner entry-level stuff. I mean actually foundation knowledge to build up to really complex understandings of systems. So you really need knowledge and especially foundational knowledge to use these tools effectively. And I hope with our courses at HEXTREE.io, we can teach you exactly that.